In this video, we will solve two problems relating to elastic collision and inelastic collision. In case you like to go to a different problem, you can see the time index below this watch icon. We will also show you how one-dimensional elastic collision problems can be made easy by a mathematical trick. So this video will be quite useful. Let's begin. This is the first question. You may pause the video and read the problem carefully. Let me proceed. Let's start. Based on the problem, we draw the figure, and to the right, we rewrite the choice of answers provided. We also mention in green what we need to know to solve the problem. I will explain as I go along. Okay. Let's write the given and ask for the problem. Here we have elastic collisions between neutron and deuteron, as shown in the figure. We use u for initial velocities before the collision and v for the final velocities. The deuteron is at rest before the collision, so we have ud, which is initial velocity of deuteron, equals to 0. The deuteron, which is isotope of hydrogen, is made up of one neutron and one proton, which is very close to twice the mass of neutron. We are asked to find the fractional loss of energy. Loss of energy is change in kinetic energy. Fractional means divide the change by the initial kinetic energy. One always divides by initial, whether it is percentage change or fractional change. It is more to do with math than with physics. The problem asks to do the same evaluation for carbon, which is 6 protons and 6 neutrons. So the mass of the carbon nucleus is 12 times the neutron mass. Now that we have given and asked, we write the equations to solve. We write conservation of momentum, which is simple. The next equation is a math trick, which is valid only for one-dimensional problems, and it has to be elastic collision. Instead of writing conservation of energy equation, we write this additional of initial and final velocity of one object equals to initial and final velocities of other object. I will show you the derivation slide at the end of the video. I feel it is a must as you can solve this problem quickly with this method. So next, we simplify the PD as follows. Now let us solve. Now it is fairly straightforward. We will solve for equation 1 and 2 for initial and final velocities of neutron, because we have to calculate PD, which is fractional loss of kinetic energy. You can do it in your own way, but since I have to explain, I will do it as follows. We rewrite equation 2 and multiply both sides by minus md. Then we add to equation 1 and we get Vn in terms of Un. The fractional loss of kinetic energy is reduced to minus 0.89. We can identify the choice 3 is the right answer. However, there is a negative sign which needs to be interpreted properly. The negative shows the loss, so if they ask for the loss, it is positive. I think you feel satisfied with the answer and we will choose 3. By the way, I forgot to mention we substituted md is equal to 2mn here. Now the answer is done. We need not calculate for carbon as we could get unique answer. It will save some time that you can devote to next question. But since I need to explain, I will proceed. We follow the same steps, but in equation 3, we can substitute Md as mass of carbon and again do the same. But here Mc is 12 times mass of neutron and we get minus 0.28. This confirms our choice 3. You can pause the video because we will go to the next question. This is another one-dimensional collision problem. Pause the video to read and understand before we solve. Let's proceed. The diagram related to problem is shown. On the right are choices provided. In the green are the necessary things that we need to know to solve the problem. It is one-dimensional collision problem and all the mass are same. Let's write given ask. One object has velocity v0 and the other is at rest. The final total kinetic energy is 50% more than initial kinetic energy, which means, for example, if the initial kinetic energy is 100, the final kinetic energy will be 150. This is not elastic collision. In fact, it is surprising that the kinetic energy has increased and not decreased. It is quite possible that one of the object is attached to compressed spring and on collision it releases the energy. Or it could be explosion due to release of chemical energy. Anyway, we need to find v2 minus v1, which is relative velocity. For example, if they have same velocities, then they are not moving with respect to each other and the relative velocity is 0. Can you solve the problem now? Feel free to pause the video at various points and solve it yourself. It will still be quite beneficial to you. Let me begin solving. From the conservation of momentum, we get this. From the energy relation that is shown in given in ask box, we get this. Note that this is not an elastic collision. Now let us cancel few things such as mass and some numbers and simplify as this relation. At this point, one can calculate v1 and v2 in terms of v0 and get the relative velocity. But that will take too much time. Can you use some creative math to solve the problem faster? This is also a good point to pause the video and see if you can solve the rest yourself. We write this relation by using a minus b whole square and a plus b whole square expansion. If we add equations 1 and 2, we can remove v1, v2 terms. We can substitute these as shown. It then reduces to square root of v0, which is the answer 4. Hope you have understood and we can move to the next question. As promised, I will now show you how a one-dimensional elastic collision problem can be easily solved with this mathematical trick. This slide shows you that for one dimension and elastic collision, instead of using conservation of energy equation, you can use very simple added velocity equation. This will make your problem from hard to a simple problem. I feel it is a must for competitive exam like JEE. The way to remember is add initial and final velocity of one object, equate with initial and final velocity of other object. Once again, it is valid if it is a one-dimension problem, also known as head-on collision, also known as collinear collision, and it must be elastic collision. You can pause the video and look at how we have derived. I have created another video explaining these steps with example. The link will also be provided in the description. That is all for now. Bye bye.